Up until now, we have dealt with linear models, and they are really useful, but they impose that a certain change in x, delta means change, gives you a change in y, or is associated with a change in y, not gives you. And if you have a linear pattern, then the same change in x gives you the same change in y, no matter what level you have of x. Okay? But this linear model, it doesn't work in every situation. For example, if you have the marginal product of labor, for example, you have either a factory or maybe you have a taxi. Okay, so if you have a taxi and you hire one driver, then what is the marginal product of the labor of that driver? It might be quite high, right? But then you hire another driver. For example, the first driver is driving on daytime, and the second driver is driving nighttime. So you have a slightly less productivity from the second driver, because the first driver has first dibs on the taxi. And if you hire the third driver, the third driver might drive during weekends and whenever someone else is sick. So that driver doesn't get too many customers, okay? Not as many as the other two. And if you add a fourth driver, the time allotted for that fourth driver of the taxi is even less. So then you have this decreasing marginal utility of labor. Okay? And what you have to ask yourself when you're faced with a problem is that should changes in x of a given size come with equal changes in y regardless of the value of x? And if you say yes, then you have a linear model. And if you say no, then most probably you have a non-linear model. Okay? So we are going to look into a case, and that is a cat food case. So ØAMET2200 would like to know what is the best price at which they can sell cat food. Okay? And you have that a high price means a large profit per can, but fewer cans. Okay? High price, fewer cans sold. And a low price means you sell more, sell more cans, but you have lower profit per can. Okay? So we would like to use data on prices and sales history to find the optimal, most profitable price. So what we know now is that if you have a high price, then your quantity sold is quite low. But if you have a low price, then your quantity sold is quite high. Okay, so you have this negative slope pattern. Okay, so we have some data. We have weekly data for 99 weeks with two variables, and one variable is the number of cans sold, sales volume, and we have the price, which is average price. Okay, and then we can just make a linear regression. So we just say regress. This is in Stata. Sales volume on average price. Okay, and we get some result, and the sales volume hat, which is the estimated sales volume by the linear model, has an intercept of 162,000 and a negative slope of 22,000, and we knew that or from a theory, we know that the slope should be negative, because if the price goes up, then you sell less. Okay? So it's a normal good, as we say in economics. And the R squared is quite high on 0.92. So 92% of the variation in the sales volume can be explained by the average price. And a standard error is of 3,000. Okay. So if we plot this, then we can. I just need my. Yeah. If we plot this, then we can actually to make this, we just write two-way and then scatter, and we are taking the sales volume, okay, on the average price. And we also would like to have the linear fit of sales volume on average price. So what we have here is we have the y hat, which is the sales volume hat, and we see that we have sales volume on the y-axis and the average price on the x-axis, and what we can see is that for low prices, our model, our estimated sales volume is underestimating the actual sales. And for medium prices, our model actually predicts sales volume above what is observed, okay? And for high prices, we see that our model again underestimates the actual sales volume. And what we can do here is that we can more easily look into the pattern in the residuals by plotting the residuals versus the average price. Okay, so this is just two-way. Sorry, and you have a scatter plot, okay, and with the residuals versus the average price. Okay, and what you can easily see here is that you have this non-linear pattern, this convex pattern between residuals and average price. So this means that we might have to perform a transformation of the data to estimate a linear model. That's next time.